Out here in the silent vastness of space lies a resource that could change everything. The asteroid belt, an ancient swirling collection of rocky fragments and icy bodies that orbit the sun, may seem like a vast emptiness, but within this darkness is a treasure trove of unimaginable value. These seemingly ordinary objects, remnants of the early solar system, may hold the key to unlocking humanity's next great frontier. A new era of exploration, wealth, and innovation is within our grasp. It's a future where the limits of our resources are no longer bound to the Earth, but instead to the stars themselves. These asteroids are not just chunks of rock. They are ancient stores of raw materials that formed billions of years ago, long before Earth took shape. They are treasure chests filled with metals, minerals, and even water resources that we will need to propel humanity into a future where Earth resources are no longer enough. What we once considered barren space rocks are now potential gold mines waiting for us to come and extract the wealth of the cosmos. Inside these celestial bodies, we find an incredible range of materials, many of which are either rare or nearly depleted on Earth. For instance, platinum, a metal crucial for advanced electronics, electric vehicle batteries, and medical devices, is found in high concentrations on certain asteroids. The amount of platinum in some asteroids is enough to meet humanity's needs for thousands of years with a supply far exceeding anything Earth can offer. Similarly, elements like nickel, cobalt, and even rare metals like gold, osmium, and palladium lie within these asteroids, enough to fuel not just industries on Earth but entire interplanetary economies. Platinum alone could revolutionize the way we approach clean energy, electronics, and sustainable industries. Asteroids like 243 Ida and 16 Psyche are rich in these precious metals. Imagine what we could do with access to resources like these, transforming everything from the way we manufacture goods to how we fuel future space missions, would no longer be limited by Earth's geological constraints. In a world where the demand for technological innovation is growing faster than the Earth's ability to supply resources, asteroid mining offers a potential solution to the challenges of our time. From the rare earth metals used in electronics to the precious minerals needed for renewable energy technologies, our planet's reserves are finite, and with increased demand, the cost of extraction continues to rise. Asteroid mining could provide a new and virtually limitless supply of the materials that power the world's economies, ensuring that humanity's technological advancements continue unhindered. The asteroid belt lies between Mars and Jupiter, but asteroids are not limited to this region. Some of these rocks are rich with metals that will be worth trillions of dollars if mined on Earth. The largest of these asteroids, such as 16 Psyche, could contain more nickel and iron than has ever been mined on Earth. Meanwhile, smaller asteroids hold significant quantities of water, potentially enough to create life-supporting systems for human colonies on the Moon, Mars, or other celestial bodies. Extracting resources from these distant worlds will require new technologies, ones that we are just beginning to develop. To mine an asteroid, we need spacecraft capable of traveling vast distances, often for years at a time. These spacecraft will need to be equipped with state-of-the-art robotics, artificial intelligence, and advanced materials science. But these technologies are not science fiction. They're in development right now. Companies like SpaceX, Blue Origin, and startups like Planetary Resources are already testing spacecraft capable of landing on asteroids and extracting materials. Mining in space is an entirely different challenge than on Earth. There's no gravity, no atmosphere, and no resources to help us process what we extract. So we will need to innovate. The idea of refining materials in space rather than transporting them back to Earth could become the norm. Processing facilities in orbit, on the Moon, or even on Mars could transform raw materials into finished products, metals, fuels, and even water, without ever having to return to Earth. Water, one of the most valuable resources in space, could be harvested from asteroids to fuel rockets, power life support systems, or even sustain colonies. Water extracted from asteroid could be split into hydrogen and oxygen, used to power spacecraft and provide critical support for long-term missions. And as humanity plans to establish permanent colonies on the Moon or Mars, this water could be used to create everything from breathable air to food production systems, paving the way for a future where humans live and work on distant worlds. But this potential comes with challenges of its own. The technology to mine asteroids at scale does not exist yet. A mission to a single asteroid could cost billions of dollars, and the mining process will be no less complex. The extraction of materials, the transportation of resources, and the infrastructure needed to process them in space will require monumental advances in space travel, robotics, and manufacturing. And these missions will face a unique set of environmental and ethical concerns. How do we manage the impact on space ecosystems? Who owns the asteroids? And who gets to control the resources extracted from them? These are questions that must be answered if asteroid mining is to become a reality. Current space law, for example, is not fully equipped to address the ownership of resources found on asteroids. In 1979, the Moon Agreement stated that the Moon and other celestial bodies should be used for the benefit of all, but it didn't define how resources would be allocated or who has the right to extract them. The growing commercial interest in asteroid mining is forcing governments, international organizations, and private companies to reassess these laws, and a new space policy framework is likely to emerge in the coming decades. Beyond the technical and legal obstacles, asteroid mining could change the very fabric of society. The wealth generated by this industry could fund new space exploration missions, support colonization efforts, and dramatically impact industries on Earth. The availability of abundant resources could lead to the development of sustainable technologies and industries that were previously unimaginable, advancing clean energy solutions, increasing access to advanced medical technologies, and propelling humanity toward a new age of innovation. Asteroid mining, when it becomes fully operational, will not just be about extracting wealth. It will be about expanding humanity's reach across the solar system. Imagine a future where cities are no longer confined to Earth, but instead extend across the stars. The construction of space stations, lunar bases, and even Martian colonies will rely on resources harvested from asteroids, supporting an entire ecosystem of off-world industry, agriculture, and infrastructure. And so, as we stand on the cusp of this new era, the path ahead is clear. Asteroid mining offers not only the promise of boundless resources and economic growth, but a chance for humanity to transcend the limits of our planet. We will not only unlock the riches of the universe, but take our first steps into a future where the stars themselves are within our reach. The resources of the cosmos await us, and as we chart our path to the stars, asteroid mining is a key to unlocking a future beyond imagination. The question is no longer whether we will mine asteroids, but when and how. The answers lie in the stars and in our ambition to reach them.